Let's take a look at this lab problem from section 7.1, number 3. Evaluate the integral, and we're looking at the integral of the arctan of 3t. Now, we're kind of forced, there's only one expression here, the arctangent of 3t, but we're kind of forced to use integration by parts because we do not know the formula for this, at least not yet. And so what we're going to do is by using integration by parts, we're going to get to split this up into two different functions, one that we can integrate and one that we can take the derivative of. Now we can take the derivative of anything, but we can't integrate everything. So we'll take u equal to the arctan of 3t, and then du or dv is going to be dt. Alright, so by taking u is equal to this, we at least know the derivative of this. I hope we do. And then we'll take dv to be the rest of that, which is just a 1 times dt. Now we can put a 1 here to say that there's this 1 there, but you don't really need to put that. You can just put dt because, you know, 1 times dt is just dt. Alright, so now the integral, or the derivative. The derivative of the arctan, if you remember, it's a big, not that big of it, but it's a little bit of a fraction. It's going to be 1 divided by 1 plus, and then the 3t squared. So it's like the arctan of x, the derivative of the arctan of x is 1 over 1 plus x squared. Now unfortunately we're not quite done yet because the angle or the argument is more complicated than just a variable, so we need to do the chain rule and we need to take the derivative of the inside. Now we could just put this in the numerator because 1 times 3 is just 3, but just so you know that this is coming from a chain rule, we have an extra 3 that comes out. Okay, our v was equal to dt, and so our dv is equal to dt, so to find v you need to take the integral of that, and the integral of 1 dt is just going to be t. So now that we know that, we're going to put it together. We have u times v, so u was equal to the arctan of 3t, v, which is what we just got, is t, minus the integral of v du. So du was 3 divided by 1 plus 3t quantity squared, which is 9t squared. And then v was t. Okay, so now we're going to take the integral of this. We do not need integration by parts again, but what we can do is we can do a quick u substitution. We're going to let w instead of u. W is equal to the whole denominator, and just looking ahead, the derivative of 9t squared is going to be something with a t in it, and that would cancel that out. So the derivative of this is going to be 18t. Now there's already a t out here, so let's not double that up. So it's just going to be 18 times t dt, and then the t's would cancel, and I'll have a 3 divided by 18 coming out. So the 3 divided by 18, it looks like they're kind of playing around with this and pulling out a 3 divided by 18. And so what actually happens here is that from the 3 that gets moved over here, and we have an 18 that pops out, so we need to multiply this by 18 again so that the 18s would cancel and the 3 would just be in the numerator. That was a little tricky, but the substitution is going to give us let's see, the 3 over 18, so the 18 will stay up here, 18 will stay up there, and then the w and then the 3 over 18 can come out here, and so we just have an 18 over w, or 1 over w, And then we know that the integral of dw over w is just ln of w, and we have an 18 over 6, which is going to give us a 3. And then we'll remember that when we figure out what w is equal to 1 plus 9t squared, so we'll put 1 plus 9t squared here. Okay, so I hope that 18 was correct, and nope, doesn't look like it was correct. Let's see what happened. So we're doing the substitution, and when we replace the w, this whole thing is w, and then we have a t, and then a dt. So they force this 3 over 18 to come out. And so when we do the replacement, the t gets replaced with 18t. So, so this 18 times t gets replaced with dw. So dw is here. So this is now just equal to 1. Let's see if that was the error. Yep, I think that was it. So now combining all we have here, we're going to rewrite this. We have t times the arctan of 3t minus, and then the thing that we just found, which is a 1/6, and then the ln of 1 plus 9t squared, and then a plus c. Okay, so hopefully that will be useful for some future integrals where we're looking at one function and we don't really know the integral of that. Okay.